Okay, the next method is going to be what we call the factor cancel. Okay, we will use basically algebra to cancel out the common factor in the numerator and the denominator of a fraction. This will look super familiar when you were studying rational functions back in Algebra 2 and in pre-calc. Okay, so what we're going to do, and it's the same process that you were doing when you were finding a whole back in the day. Okay, so why we do this? Okay, so the first thing that I do, following the previous page, you plug the 4 here, here, here. Okay, so when you plug the 4, you have 16 minus 4 minus 12 is going to be 0. And then you have 4 minus 4 is 0. So that's not good. Okay, I cannot conclude. Whenever you have 0 over 0, you cannot conclude. So that's why I put the sad face. I'm like, no. Okay, so I need to do something. And what we can do here is obviously factor. Okay, so we factor the top. You know that the factors here are going to be x minus 4 times x plus 3. Okay, and then it's going to be divided by x minus 4. Here you realize that we can cancel them. Okay, and here I forgot to put the x goes to 4, so please remember to do that. Okay, after that you have, okay, so the limit when x goes to 4 of what? X plus 3. Okay, once we have this, you can evaluate and put the 4 there, so you know that this is going to be 4 plus 3, which you know that this is going to be equal to 7, and that's it. Okay, now let's do the second one that we have over here. Okay, when you plug that, what happens? Okay, so you're like, should we factor this one? Let's see. Okay, you can, but you can plug it there, right? If I plug it there, what do you have? You have 3 minus 2. It's going to be divided by 3 times 3. 9 times 3 is 27. Minus 8. So that's a number. So I have that this is 1 over, what? 19. So do you really need to factor it out? Not really. I mean, you can, but you don't need to. Okay? So you just need to learn how to be, let's say, tricky here. I'm pretty sure the meaning it was that this was a 2. Okay? And I'll do it in a second. Okay? So for this one that we have over here, what are you going to do here? Okay, you're going to tell me, oh, it's pretty ugly. That's true. Okay, so what I'm going to do here is I'm going to divide everything by 2 to the power of x. Okay, so this is a very interesting method. I'm doing this because when I plug the 0 here, 2 to the power of 0 is 1. 1 minus 1 is 0. Divided by what? Plug the 0 here, 2 to the power of 0 is 1, minus 1 is 0. So again, you have this sad situation where you have 0 over 0 and you cannot conclude. So the only way that we have here is I would divide each one of the terms by 2 to the power of x, and you're going to see it here. So you have the limit when x goes to 0 of 2 power x divided by 2 power x minus 1 divided 2 power x divided by 2x divided 2 power x minus 1. Okay, so you have all this situation and you're going to tell me, oh, it looks awful. Wait, there's a lot of things that we can cancel. This becomes a 1. Okay, so we have that this is going to be equal to the limit when x goes to 0 of 1. This one stays the same. Okay, this one we can cancel because you know that you have the 2 to the power of x and 2 to the power of x. Okay, if you remember from algebra 2, you have that 2 to the power of x is the same as 2 to the power of 2 to the power of 2 times 2 to the power of x. So from there, you know that this cancels with this one. Therefore, the only thing that you have is 2 to the power of 2, which is a 4. Okay, here. And this one, you know, you cannot cancel anything. Are we okay with that? Making it easier, you have that this is going to be equal to the limit when x goes to 0 of 1 minus 1 over 2 to the power of x, 4 minus 1 divided by 2 to the power of x. Now what happens when you plug the 0 here and here? When you plug the 0 here and here, this becomes a 1. 1 over 1 is going to be 1. 1 over 1 is going to be 1. Therefore, you have that this is going to be 1 minus 1 divided by 4 minus 1, which is going to be equal to 0 divided by 3. And surprise, surprise, this is 0. Okay, so that's going to be your limit. Okay, moving on to more stuff and things. Another method that I love is the conjugate method. Okay, the conjugate method is used when there's a radical involved, and again, you have this situation when it's going to be 0 over 0 or infinity over infinity. Okay, so it's pretty simple. It only has one trick that I'm going to explain in a second. We multiply the numerator and the denominator by the conjugate. This will most of the time create a common factor that will cancel. Thus, it will eliminate the indeterminate form. So here, when you plug the 4 here, what happens? You have 0 again at the top, and then at the bottom you have 0. Again, we are very sad because we have the 0 over 0, so you don't want it. So what are you going to do? You are going to take your limit when x goes to 4, and then you have square root of x minus 2 times something. Okay, you copy this one, and now what are you going to do the conjugate? The conjugate, you need to change the sign of the radical part, meaning you are going to multiply times negative root x minus 2 divided by negative root x minus 2. Please note that I changed the sign of the square root piece. Okay, I didn't change the sign of the constant piece. Okay, so here you just need to do a little bit of algebra. Please remember to put the limit when x goes to 4. Okay, so you multiply root x times negative root x, that's going to be negative x. And you multiply root x times negative 2 is going to be negative 2 root x. Then you multiply negative 2 times negative root x, that's going to be positive 2 root x, and you know that they are going to cancel. And then negative 2 times negative 2 is positive 4. And then at the bottom, the key here is leave it like that. Do not distribute the denominator. Okay, so leave it like that. That's a huge key. Leave it like this. Do not distribute, because if you distribute, then you are going to complicate the equation. Here, when you combine terms at the top, these two cancel. You are going to have something really nice. You have limit when x goes to 4, and actually you can take out the negative. Okay, so you have, I'm going to write it completely so you see. Negative x plus 4 divided by x minus 4, and then you have negative root x minus 2, and you're going to tell me, well, they are not equal. Indeed, okay, but you know better. You know that you can take the negative as a common factor here to cancel it with this one. So that's what I'm about to do. So you take out the negative, you have x minus 4, then you have in the denominator x minus 4. With the negative here, you can take out the common factor or not of this part. You cancel this 2, keep the negative. Remember that we have that beautiful negative in front, so don't forget about it. Okay, and then you have the limit when x goes to 4 of negative 1 divided by negative root x minus 2. Okay, after that you can tell me, oh, so now can we plug it in? You tell me yes. Okay, so you have that this is going to be equal to negative 1 divided by negative root 4, which is 2, minus 2, which is going to be equal to negative 1 over negative 4, which you know that it's 1/4, and that's it. Okay, so for the next one, what we have is, would we use the conjugate method? For this one, why or why not? Okay, so let's plug the 3. When you plug the 3, this becomes a 0, and this one becomes a 6. So, do you need to use the conjugate method for this one? You tell me. No. Why? Because 0 over 6 is something. What is that something? Okay, so we know that the limit when x goes to 3 of root x minus root 3, x plus 3 is equal to root 3 minus root 3 divided by 3 plus 3. This is 0 over 6, and surprise, surprise, what's 0 over 6? 0. Okay, so you don't need to use the conjugate method, because when we evaluate the function at 3, we get a value, which in this case is 0. So your limit is 0. Okay?